are back, returning with our trigonometry here. We'll work with no new calculations, but we'll work with some word problems, looking at angles of elevation and depression specifically. Our prerequisite skills for this, we're relying on skills that we've already built on in this course. We're relying on our ability to label right triangles with our opposite, our adjacent, and hypotenuse. We're relying on our ability to choose a trig ratio using our SOHCAHTOA, and we're relying on our ability to work down to show our work and follow along. We'll work first with an understanding of our angles of elevation and depression, right? So an angle of elevation or an angle of depression, either way, it comes from somebody looking out, right? So if we look straight across, that has an angle of elevation of 0 degrees, an angle of depression of 0 degrees. If we look up a little bit right here, that is looking up at an angle of elevation. If instead we look down from the horizontal line, that's looking down with an angle of depression. Now the key here is that both of these angles are measured from this horizontal line. You will likely make a mistake at some point accidentally measuring an angle not from the horizontal line. I want you to be really, really careful. Always measured from the horizontal line either down or from the horizontal line and up. So we'll work with Pipi the pirate, standing on the top of a cliff that is 86 meters high. She spots the black pearl at an angle of depression of 24 degrees, and we need to know how far is the black pearl from the base of the cliff. Fantastic. So we've read this once. Now it can be really helpful, particularly with word problems, to go back and read it again. We've already highlighted some key pieces. We want to read it again to try and come up with some kind of a diagram. Pipi the pirate is standing on top of a cliff that is 86 meters high. Fantastic. Here's our cliff. Here is our pirate. Maybe our pirate should have at least a wooden fake leg. There we go. And standing right up top right here, looking down at an angle of depression of 24 degrees. So we'll need to be careful. Remember, we're measuring from that horizontal right here down at an angle of depression of 24 degrees. And then we're asking how far is the black pearl. Remember, that's what's being seen right here. There's our pirate ship. How far is this from the base of the cliff? So that's our unknown side length. We can assume this cliff is 90 degrees up. And all we're doing is we're finding this unknown. I encourage you pause the video here because you can solve this using only your prerequisite skills. But I'll go through it right here. We're working, if our angle of depression right here, this is actually outside of our triangle right now. So we could use a couple of ideas. We could use a Z pattern right here to recognize that we also have a 24-degree angle inside our triangle right here. Or instead, if you would rather, you can recognize that we have a sum of 90 degrees right here. 24 degrees is on the outside, so that leaves 66 degrees that we would be working with on the inside. I'm going to work with the 24 degrees on the inside down here. You can choose whichever. You should end up with the same answers, but it might complicate things if you accidentally label two, or if you label two angles inside, because you need to make sure you're only working with one angle when you're choosing to label your sides, right? So if I'm choosing to label from here, then I know my lowest side here is my adjacent side. I know that what I'm looking for is that adjacent side, and I know, oops, I'm missing a piece of information here. I know as well that my opposite side is 86 meters high. So if that's the case, I have an opposite side, I have an adjacent side. I know I'm working with my tangent ratio because of SOHCAHTOA. So the tangent of theta is equal to my opposite side over my adjacent side. I'm now substituting in the values that I know. The tangent of 24 degrees is equal to my opposite side, that's 86 over x. Nice and easy. I can multiply both sides by x to get it up into a numerator. These cancel out on the right. I'm working with x times the tangent of 24 degrees equals 86. My pirate ship is getting in the way a little bit, so I will move a little bit down here. Nice and easy. Here I want to multiply, or divide rather, both sides by the tangent of 24 degrees so that I can isolate my x value. Nice work. These cancel out. I'm working with x equals 86 over the tangent of 24. I can calculate that right here. 86 divided by 24, and then I'll make sure I take the tangent of this to end up with 193. Does that answer make sense? I think it does. What I'm looking for right here to see if this answer makes sense is I'm checking to see, remember, opposite of a very small angle or a relatively small angle like 24 degrees should be a smaller side than adjacent to it, because always if this angle is 24, we should have a bigger angle up here. We're expecting a big side opposite a big angle. You don't necessarily need to memorize that, but that's what my brain is checking to make sure that our answer seems reasonable. Next, what I want you to do, I want you to take a look at my solution right here. I've already attempted a solution at a problem, and I need you to try and find any mistakes. I encourage you, pause the video here, try and find them. I will go through them in 2 seconds here. Good, so we have a 24-foot tree. Oops, a 24-foot tree. It is casting a shadow that is 16 feet long. We're looking for the angle of elevation of the sun. First, we'll double check our diagram. We'll make sure that things are labeled in the right spot. We have a 24-foot tree. That seems to make sense. We have a shadow that's 16 feet long. Those make sense as well. Now, here's our key, this angle of elevation. Remember, angles of elevation are always measured from the horizontal. This is not. Neither of these side lengths that this angle is on, neither of these side lengths are horizontal. I have a vertical one right here. I have an angular one over here, but I do not have the horizontal. And that's the mistake right here. This angle theta that we might go through and try to find, let's take a look. They set it up with I set it up with the tangent of theta equals opposite over adjacent. That makes sense. I'm working with my opposite and adjacent side length, so I know I'm working with the tangent of theta. Looks like they substituted in, or I substituted in, opposite is 16, adjacent is 24. Looks great. Looks like an inverse tangent function right here. That's a great idea to isolate for our theta. We could show our work a little bit better right here by showing this inverse tan on both sides. Is that 100% required? No, it's not. It might be able to help you follow what was done here. And lastly, they've taken that inverse tan, they've calculated it and found 34 degrees. All of the calculations here are 100% correct. The problem is they didn't answer the question, because the question is asking us to find this angle up here. This is our angle of elevation, right? So if we're working with this angle of elevation, I know that this angle of elevation and the angle that was calculated are 34 degrees here. They should add up to 90 degrees, right? Because these angles together go from a perfectly vertical line here to a perfectly horizontal line here. So if we know they add up to 90 degrees, then I know that 90 degrees is equal to 34 degrees plus, we'll call it angle of elevation right here. That means I can subtract 34 degrees from both sides. Nice and easy. I'm working with my angle of elevation is something like 56 degrees. There was no mistake with the calculation. The mistake that was done was not finishing the problem, was not recognizing that our angle of elevation needs to be labeled up here. So I'm hoping at this point you're feeling a little bit more comfortable with your angle of elevation. Nice work.